Good morning. Wow, there was like 4 people there. Good morning. There we go. Excellent. Thank you very much for coming to the second session of the day on understanding the Azure Stack. My name is Matt McSpirit. I'm a technical evangelist for our data center technology, our on-premises technologies. So I focus on Windows Server, System Center, the Operations Management Suite, and also this thing we call the Azure Stack. And the Azure Stack is something you may have heard a little bit about. We talked about it in the keynote. Brad Anderson mentioned it, name-dropped it, and hopefully excited you about its potential, but didn't really show a great deal. So in today's session, I'm going to take you through a lot more depth about the Azure Stack, both from a consistent service consumption perspective right through to some of the plumbing that underpins the Azure Stack. Now, my role at Microsoft is, as I said, a technical evangelist. You may be wondering, well, what does a technical evangelist do? Well, there's a couple of us on stage at this point. There's a few of us around the conference as well. And our role is essentially to give you a view of the technology. Sometimes it's far into the future technology that's not going to be available for a little while. Azure Stack certainly fits into that category. So give you a view into the technology, what it does, what it looks like, but we don't have to have the added responsibility of understanding how it's licensed, which is a big win. Yeah, woo, we can just focus on the tech and the cool stuff. And that's what we're going to talk about today. Now, there's a bit of context setting in the session. We want to make sure you understand why Azure Stack is important. What are we aiming to solve with Azure Stack? And then we'll go into some of the technology, how it works, how it presents itself, what the plumbing is under the covers as well. So hopefully you'll get a lot from the session, and we'd love to hear your questions, your feedback towards the end as well. You'll see some strange chap on the front, on the stage with me here. Because we're such a hybrid strategy going forward, we thought, well, I'm the on-premises guy for our tech evangelists in Microsoft Corp. We've got the cloud guy as well. You might recognize him with the hat.
It's just about your premises or mine. That's what it is,
That's
right?
it, yeah, your premises or mine. And Rick and I are going to take you through a lot of hybrid stuff in Azure Stack and a lot of borrowings and learnings that we've made from Azure. So it makes sense to bring up, it makes sense to bring up my Azure colleague to talk to us about some of that stuff and how you can start to utilize it today. So without further ado, let's have a look at what we're going to cover. Firstly, I'm going to introduce the Azure Stack and what it's all about. In the context of transformations in IT, it might not be something that's hit your infrastructure currently. You may still be in what you class as quite a traditional infrastructure, managing with traditional management tools. But as we go forward and we think about how consumers are consuming cloud services, public cloud services, and how we can start to get control of that on-premises, that's where the Azure Stack is purely square, front and center. That's where it's going to help you. We'll look at the tenant experience, so how your users consume Azure Stack and what that looks like, how you deploy applications, this big thing called Azure Resource Manager, and how that, in Azure Stack, plays a significant part in how you deploy and consume applications and workloads. We'll look at services and some of the plumbing, the compute, the storage, and the networking that presents itself abstracted to your tenants and consumers, and then we'll wrap up with some useful resources. So it's jam-packed. We've got loads of stuff to talk about and show. So when we think about some of the reasons and the context about why Azure Stack is important, we think about what's going on in IT today. Now, Gartner say that 40% of IT spending is actually being spent on non-corporate IT assets. So people are going around IT to get what they need. Because the drive, the desire for applications and services and the speed at which they're required can't always be met by IT today. There's a lot of procurement process. There's a lot of hoops to jump through in order to satisfy the demand of business units such as development teams, test teams, application owners, and so on. So they're looking for the quick, I need this application or workload now, and IT has a lot of process in place that means they can't get that as quickly. Well, with cloud services, Azure as an example, I can go on, I can put my credit card in, I can hit the portal, and I can have a virtual machine or an application or a full SharePoint farm in what, minutes, 5 minutes, 10 minutes? That's agile. And that's why there's a lot of this turbulence within the environment. That's why 40% of the spending is going outside of IT. But IT needs stability and predictability, because otherwise there's a lot of risk. It's difficult to manage. So we need to find that balance. And that balance and that middle ground is cloud service delivery. How can we bring those cloud-like experiences that application owners, developers, and so on are looking for, but bring it into an environment where you are under control of it and you can manage it effectively? And that's essentially what Azure Stack delivers. When we think about this innovation that's taking place, your environment, I'd imagine that the vast majority, if not all of you, are virtualized, at least a decent percentage of your infrastructure. So we've hit a point where efficiencies are at a good level. We've consolidated, we're saving huge amounts of power compared to the physical world, but virtualization on its own can only take us so far. When we think about the applications that you can run in Azure and deploy very quickly, as I referenced earlier, there's a significant innovation going on there, and that's why those application owners, those devs, are turning to the cloud. We want to blend those. We want to bring that on-premises with Azure Stack. But it really is bringing those cloud, those next-gen applications to on-prem, as well as traditional apps, which we'll talk about as well. But it's important that we get out of this mindset of VMs and servers. I need a server to do X. I need a VM to do Y. And we think about the applications, and we abstract all of that plumbing and that infrastructure away and present our users with an abstracted view that they can consume in an agile and flexible way. But when we think about a traditional data center and compare and contrast it with Azure, traditional data centers got a lot of physical servers running virtualization. There's a tight coupling from particularly applications right through the stack potentially to the metal. So applications have very specific dependencies. Maybe they're traditional legacy applications. There's also a lot of specialized hardware, like SAN as an example. SAN is a specialized hardware component providing storage. When you think about some of the proprietary and traditional network infrastructure, it's very specialized. Compare and contrast that with Azure, where everything is standardized on lower cost, x86 servers, industry standard storage, spinning disks, SSDs, hard disk drives, and networking is delivered through software definition, so software-defined network virtualization, because it gives us that agility. If you think about the amount of changes that take place in an Azure infrastructure globally every day, just from a networking perspective, there's tens of thousands of changes that get made every single day. But there's not somebody plugging in cables as rapidly as possible, like an old telephone exchange, just sliding along some kind of rack, plugging things in. It would just not scale. So traditional data centers going towards this Azure approach offer us an increased level of automation, but we can still standardize through consistent delivery of services, utilizing the powerful automation tools to enable us to do that. Now, when we think about the people, because it's not just about the technology, as I said before, now developers, application owners, business owners, and so on are circumventing IT to get their applications and things that they need. That's a type of user that requires that. It's not a traditional user who's just consuming email. We're talking about different types of users who are consuming your IT services. So there's a change happening in the industry from just traditional users and traditional admins like you and I to this concept of, in a cloud service delivery model, you and I become the providers of infrastructure and services to our consumers, our customers in IT. So we are selling our services, potentially there's chargeback, but we are providing our services to these customers. And these users and administrators, they now take on slightly different personas. So at the front end, these customers who are consuming your resources, they could be developers who have very specific needs. They want to use their own tools like Visual Studio or custom tools. They want to be able to consume the infrastructure that you're providing and the services in a programmatic way that enables them to work most efficiently. But then you've also got the ops team who wants to deliver applications and services on top as well. But under the covers, you as service or infrastructure admins, and the two are very distinct roles as we'll learn as we go forward. The infrastructure admin's very much about getting the storage, the network, the compute layer plumbed together so it's ready as a foundation. Then the service administrators are defining just what services get consumed by the tenants. Services like database as a service, infrastructure as a service, network as a service, whatever it may be. That's where your service admins come on. It might be that you're both of those personas. You provide both roles if you're a smaller environment. But certainly larger environments, we're seeing that split responsibility. I'm looking after the infrastructure and how it all fits together. I present you with this abstracted layer that you define your services, and you present those services to the developers and the operations up front. So when we think about solving those challenges and how we meet those head on, that's where Azure Stack fits. It's taking our Azure experiences, our learnings, and our code, specifically in Azure, and bringing it on premises in multiple layers. So at the foundation, we've got this cloud-inspired hybrid infrastructure. What does that even mean? Well, it's taking our learnings from Azure and running key components at hyperscale with millions of users accessing systems every day, hundreds of thousands of servers being deployed and managed in Azure, And we're bringing those learnings to you through some of the key products like Windows Server, System Center, and so on. So features like in our networking stack, the software load balancer that I'll touch on later on comes from Azure. The networking controller comes from Azure. From a Hyper-V perspective, there's new capability in the Hyper-V vSwitch to enable increased performance, comes from Azure. But at the same time, on-premises technology that we develop does get pushed up to Azure as well. So it's a great cycle that we've got, and we're uniquely placed to be able to do that because we've got that hyperscale cloud, and we've got those powerful on-premises technology. So we take that cloud-inspired hybrid infrastructure, that plumbing, the compute, the storage, the networking, the cool stuff there that we'll explore later on. And we layer on top of that the ability for you to deliver services, customized services that are unique to your infrastructure, or generic services that you can share from Azure. So for instance, in Azure, if you go in, you can see that there's a lot of services you can consume, from virtual machines, more complex virtual machines that are multi-tiered, straight through to websites and SQL databases as a service. We want to bring those on-premises as well, but complement them with your own bespoke services that you want to build that are more specific to your line of business apps or whatever it may be. But the grounding there is that it's cloud consistent. So if I build something and I invest in a development team that builds me an application that's designed for our on-prem environment, because it's Azure consistent, we can take that app and we can also deploy it to a cloud environment running in an Azure data center. Maybe we want to take advantage of the hyperscale functionality within Azure, or the scale that's available to us. So it is a cloud-optimized app platform supporting the latest and greatest frameworks, but also app packaging types like containers. We also want to enable that in Azure Stack on-prem. So that's those three key layers, and we'll explore those more as we go forward. So to reinforce that consistency across both, on the right-hand side, you've got Azure. You never have to worry about the plumbing in Microsoft Azure. Not at all. You don't go in and think, I wonder if they're using Broadcom NICs, or I wonder if they're using Intel, or whatever it may be. It's just not relevant. You go in and you say, I need a VM, I need it to do this, I need it to be this big, go. And within a couple of minutes, you've got it. You don't need to worry about that plumbing. But on-prem, you might have to look after the plumbing if that's your role. So you've got to think, well, I need to define the infrastructure, build this infrastructure that's going to be utilized by these services. But in order for it to be consistent, you've got to build it in a certain way. And that's where our Azure Stack comes in by helping us define that cloud-inspired infrastructure, compute, storage, networking, so virtualization with Hyper-V, our storage stack and our networking stack combining, and then we abstract on the plumbing. So we provide a consistent view, whether you're on premises or in the cloud, to those portals and those IaaS and PaaS services. So no matter whether I'm delivering and building an application that I want to deploy in Azure today, and I invest in that and make time and effort, when I deploy it on premises, I don't necessarily need to tweak it so much to get it to work with my on-premises cloud-inspired infrastructure, because we've abstracted it all away. And we'll talk about some of the ways we do that and how we present that information a bit later on. But it's not just about Microsoft stuff either. You'll know if you've used Azure today, you can deploy Linux VMs or Linux services, MySQL databases, and all sorts of stuff that isn't Microsoft-based. Docker containers and Linux VMs and whatnot. And that's very reflective as well of what we're doing on premises. Hyper-V is a great virtualization platform for Linux workloads, virtualizing them, running them, whether they're appliance-based, whether they're custom workloads that you're building, whatever it may be. So we're delivering a platform that's not just about Microsoft technology, but it's also about the next generation of Linux and non-Microsoft stuff as well. FreeBSD is another example. So we're really providing a suite of technologies in your data center that is consistent with Azure. And that means we can take advantage of the ecosystem, because when we deploy Azure Stack in our data centers, we take advantage of the Azure technologies, bring it on-prem, but we also expose, because of that abstraction layer, the ability to consume the ecosystem that surrounds Azure today. And that ecosystem consists of virtual appliances. The marketplace is very rich with websites and other applications, content management. Just go to the Azure marketplace and you see a ton of stuff. And now, because we've got a consistent story on-prem, and when I say consistent, it's the same, we can take advantage of those. And that's a big deal, because it means that our ecosystem is applicable to a vast array of clouds, not just Azure, but your on-premises, mine, service providers around the globe. And it means that we've got complete flexibility to move workloads if we choose to do that. And portability is very important for an agile infrastructure. So I want to show you a little bit about what it looks like to consume Azure Stack. So let's put our tenant hat on. I'm going to show a demo shortly where we consume a bit of a dev angle, but also an IT pro perspective as well. But ultimately, at a high level, what does it look like? Well, it looks pretty slick. You say, well, it looks like Azure. Yes, exactly. It looks like Azure. It is Azure running in our data center. But it's the Azure stack. It's on premises. It's under your control. But that consistency with the new Azure portal, so not the classic one. You won't find the classic Azure portal, the old portal as you referred to it in your session yesterday. It's the new, the preview, the portal that's currently in preview. That's what we will present to you through Azure Stack on premises. It's rich, it's fluid, it's slick, it's a great experience, but it's also available through programmatic means as well. So it's not just about the UI, of which we all know and love and we can click through and do what we need to do, but for developers who need to programmatically publish applications, deploy workloads, that's very important, and that's where we're very, very strong in this portal and the preview portal as it stands in Azure. And it also gives us capabilities that Rick will talk about, things like role-based access control. So we've got a great way of controlling who can access what. And we'll go through that in more depth as we go forward. And that tenant experience is split into layers, some of which we've alluded to already. So you've got that front end, that rich web portal. We can consume what we want to consume through UI or programmatically. But then under that, powering it all, the brains of the operation, if you will, is this Azure Resource Manager. Code we've taken, again, from Azure, running on-prem, and that executes what you want the portal to do. So I want a new virtual machine, or I need a website, or whatever. It executes that against the underlying plumbing. Now in Azure, that plumbing you never need to know about, as I said. But on premises, that plumbing is your servers, your storage, your networking. So that resource manager is tying in to what we call resource providers for compute, for storage, for networking, and pulling the strings. So when you define an application, let's say, as an Azure Resource Manager template, which Rick will demo shortly, in that template, it's containing what do I need for storage, what do I need for networking, what do I need for the compute layer. And then it talks to those resource providers and deploys the necessary infrastructure required. So that's where those layers come in, and we're going to explore each of those layers through the remainder of the presentation. So at the top level, that tenant portal, and I'm going to demonstrate this so you can see it in a bit more detail. But the key thing we want to get to for organizations, because of that consistency, is the ability for your developers, your application owners, to define applications that they write once and then deploy wherever they like, whether it's on premises, in Azure Stack, whether it's at a service provider that you work closely with, or whether it's into the Azure cloud itself. Without re-engineering the application, without additional work and effort, just take what you've built, write once, deploy wherever you like. And containers is a big enabler of that. Container technology, new in Windows Server, can certainly help with that portability. But cloud-based applications, generally speaking, we want to enable that seamless and streamlined development and deploy wherever you like. Utilizing the tools that your developers, your application owners are using today. So tools like Visual Studio, custom tools that they may use. PowerShell is another example. We've got that access to that ecosystem for a lot of pre-built infrastructure that we can consume in the Azure marketplace and in the ecosystem. And we present that through that Azure portal. So let's take a look. Let me just log in. Now, as I alluded to in the intro, Azure Stack, as it stands, is at quite an early stage in development. So I've got a capture that I can show you that will walk you through the experience. Firstly, thank you, my glamorous assistant. You pressed it so well. Walk you through the tenant experience from Azure initially. So we get on the right page and say, okay, that looks pretty slick. I can get used to that. And then we'll dive into what it looks like in Azure Stack. Okay, so you should see, if my messaging has been on par, that they are very consistent. So what we're looking at here is an internal look, an internal view of the Azure portal, the full public cloud, but it's just on internal servers. So this is the full Azure cloud. We're logged in with a Microsoft account in this case, and I'm going to bring up this PowerShell view. And what this is going to do is essentially, against our public cloud, we're going to essentially deploy an application. We're going to deploy an application using an ARM template that I alluded to earlier, and Rick will demo shortly. An ARM template that defines what this application needs in all of its requirements across compute, storage, network, and essentially stands up that application. So that's what we're going to define. You don't see the details of this at this stage, the application. What we do see is that I'm connected to the public cloud. This is a friendly name to define our Azure subscription. If you wanted to check the GUID, you would be able to see it was a public subscription. We saw it earlier on. We're connected to the Azure cloud. There's our credentials and our accounts. But this is a full Microsoft Azure that we're going to run this particular command against. And you'll see it's going to deploy it against the West US data center. It's going to take an input of the resource group name. So a resource group being how we collect and group all of our resources that make up this application. Virtual hard disks, virtual network adapters, public IPs, whatever it may be. So they're all grouped together. So we're going to give this a name, in this case, of AZ Demo 44 for no other reason than the random number that they picked. And this is going to go ahead and deploy into Azure. You think, okay, 3 lines of PowerShell, and that's pretty magical. But the real detail is contained within that template file, and we'll see what one of those looks like a bit later on. So what's essentially happening now in Azure is that deployment is taking place. So we go back to the portal, we have a look in our resource groups. So you'll see in full Azure, when he brings up the resource group view, there's a lot of stuff that we can consume. There's a lot of things that we have access to. When we look at Azure Stack later on, that list is reduced. We don't present everything in Azure Stack, but it's also consumable based on what you allow people to see. So he's logged in, he's in his resource groups, he brings up AZ Demo 44. Remember, this is all in the public cloud. And you'll see we can drill into what resources make those up. The task is currently running, so it's not finished. It will take a few minutes to deploy the VMs and connect all of the networks and so on. But you can see the assets that are actually being provisioned. Some of them are already complete. So NICs, storage accounts, and so on. Everything that's required for this application that's been defined in that ARM template. Okay, so it's encapsulated within a JSON file. Now, if we go back a little bit, we can see in public Azure, and this is unique to the preview portal, it wasn't in the old one, the ability for us to specify role-based access control. So who am I going to allow to administer this particular application we're uploading? Not access it in terms of as somebody who could access this website. We're talking about who could manage it. And I can delegate control to different people. So for instance, I could make Rick an administrator for this application we're uploading. He could make tweaks to the app and so on. And that's how we use role-based access control. So we drill in now, we'll see those key resources that have been deployed. You'll see there's virtual machines. This is one we deployed earlier. So this is one that's already pre-built. You'll see there's NICs, public IPs, storage accounts, SQL databases, the web front end for the application. All of that has been deployed from that single template. So it's quite a complex app with multiple moving parts. But we defined it in the template, and we just deploy it consistently. That's that standardized service approach. We can deploy multiple instances of this very easily. And if we browse to that Bill's Coffee Shop application, when the browse button becomes available, you'll see it'll launch, and it'll run essentially an Azure website. And if any of you have ever built an Azure website today, you'll know before you do any tweaking of the domain name and the fully qualified domain name, it will just create it with whatever you called it, .azurewebsites.net, for instance. So you'll see that's what we're accessing, and there's the website. So that's essentially a walkthrough of how you would do that in Azure, utilizing something like an ARM template to streamline all of that. Now, if you're an IT pro, you think, well, I've never used ARM. I've not used any, I don't need to do that. I do all of my templates in virtual machines. I make them in a rich GUI and so on. This is a change, and absolutely it is. But you can practice today in Azure. You can use it today in the preview portal and get used to it and see what, and we provide some samples as well. Now, if we flick over to the Azure Stack script, this is what Brad in the demo is looking at here. He's looking at what's different. Because now we're going to focus on taking that same example application and we're going to push it to Azure Stack on-prem. Now the key things that we want to make are different. We need to flick over the subscription first. He's going to go to his other PowerShell window. So he's flicked over the subscription. Now this PowerShell experience is focused on the Azure Stack connection. So he's essentially pointed PowerShell at the Azure Stack. There you see the info. Anybody who memorized that GUID? Looks different, right? Yeah, it's not the same GUID. Otherwise, you can just look and say private demo. That is the friendly name. We are now pointing at the Azure Stack environment. Okay, so we're focused on the on-prem equivalent. And the environment variable, the Azure resource endpoint that we're looking at there is azurestack.2015-demos.com. So we're essentially saying now I'm going to run this script that I took from push to public cloud Azure. Now I'm going to run it against on-prem Azure Stack. So that's what we're essentially calling out here. No change, streamlined, easy to grasp. So I'll let Brad flick on a little bit here. Come on, pal. Stop talking. There we go. So he's going to run his core, same application, same command, no change, but we're going to run it now against Azure Stack. So he executes that. It asks for a resource name. Doesn't matter what he calls it, really, in this instance. He could call it whatever he likes. But in this case, we could call it exactly the same. Because remember, one of them has been pushed up to Azure Public, This one is published to Azure Cloud on premises in the Azure Stack. So it doesn't really matter what he calls it. It's irrelevant. So we'll go to Azure Stack, and he's purposely made it a different color, so we know that we're looking at the Azure Stack, and as if the title and wording isn't enough in the, on the screen there. But this is Azure Stack. Looks and feels and is identical. It's consistent. However, you'll notice that there aren't as many options for you to consume as what you'll see in the full Azure cloud, and that's intentional, certainly at this stage in development, but also as we go forward, we won't present everything you can do in Azure to Azure Stack. It wouldn't make sense. But we drill into the resource groups view. There's that AZ demo again. In this case, the subscription is the private demo. And what you'll see, the task is still running. That ARM template is still executing. We're still deploying the workload. But notice it's exactly the same process. It's completely consistent. So we see what's happening. We're deploying NICs. We're deploying public IPs. We're deploying the virtual machines that will house these applications, the web front end, and so on. And just as we saw before, if we look at one that's pre-made, there you'll see you can bring up, that one's already been deployed. There's 10 resources, the VMs, the NICs, the public IPs, and so on that we see. All of the things that make up this app, it's exactly the same as what we're running in Azure. And if we bring up the web front end to show us exactly what this looks like, you're going to find, lo and behold, it actually loads a bit quicker than Azure when it's on-prem as well. Hey. Take that. Oh, look. And there you see, it's on-prem. There's your web front end for the freshly brewed coffee app. So you've seen how I can take an application. Obviously, we didn't go through the nuts and bolts of how that app is made yet. Rick will go through some of that a bit later on with a different application. But you'll see how quickly we can take stuff we've built and choose where we want to deploy it. Now, he's looking here on-prem. We're looking at the RBAC controls that exist. We took them from Azure. We bring them on-prem, so I can define who on-premises in our Azure Stack environment can administer this application. Remember, this is different from who can access that web page. Anybody can access the web page, the coffee shop, and buy coffee. That's irrelevant. What we're saying here is who can access and manage this particular application, who can make changes to the app. When we think about developing this application, you don't need to read what's in the middle. I know it's small on the Visual Studio. It's not too relevant. What I want to call out here is if I'm developing this application, we want to make sure that we give you a helping hand on how you can build apps. So in Visual Studio, when you go to a new project, you'll see there's a specific project type called Azure Resource Group, which gives me a helping hand. It enables me and gives me a big head start on how I start to define applications that I want to deploy to the Azure cloud. Notice I'm not saying Azure Public Cloud or Azure Private, just the Azure Cloud, because I define these applications using this kind of approach, and I build once and run anywhere. So you'll see when we open those, it prompts you for a number of starting points. Do I want to create a web app or a virtual machine with a load balancer? And you'll see if you ran this today, you would find there'll be more options, I'm sure, as we go forward, as this gallery expands. It's not just Microsoft, it's Ubuntu, it's Docker on Ubuntu, there's other Linux stuff in there. So we're giving you that starting point. And when you launch one, you'll see there's lots of parameters and variables that it's asking you for in order to help you to build these applications and define these application templates that you can then deploy your applications from. I even had an error in the demo that I left in specifically, just ran out of memory. It's just a lot going on. So when you see when we expand these the parameters, the variables on the left-hand side, you'll see, okay, these are the kind of things that it's going to ask me for: admin passwords, images, image SKUs, and so on. Each one will be specific to each template. But when it comes to deployment, this is where it gets easy. I say easy, very easy. I simply say, okay, who am I? Log in. And in this case, because my credentials are tied to subscriptions in Azure and Azure Stack, it picks up that I could actually be deploying here to Azure Stack or Azure, based on who I am. So if I'm a developer in Visual Studio and I've got my Microsoft account, it's going to know you've got access to all of these different subscriptions. Here he chooses Azure Public Cloud to start, and that's all of his specific subscriptions that he's got access to in Azure. He chooses which one he wants, which resource group. There's the one we deployed earlier to Azure, and then we can go ahead and deploy an application. On the contrary, on the flip side of that, if we chose instead to do the Azure Stack, we'd see essentially the resource group that we created earlier on. So we're very straightforward. There's our Azure Stack view. We've only got one subscription when he brings it up. There we go, the Brad's private demo that we showed. And then you'll see when he clicks on that, come on, Brad, there's our resource group. There's our AZ demo 44 that we just created. So we could deploy applications into that resource group or create a fresh one. So that's just showing some of the development experience that you get when you're building applications and getting ready to deploy them to either Azure Stack or the Azure Public Cloud. But to give you another example of the consistency between Azure Stack and Azure Cloud, we're going to bring up a little application here that's an open source app that's available on GitHub that you're able to essentially explore and manage to a certain extent your blob storage in Azure. This was built purely with Azure in mind for me to administer and maintain my blob storage. No concept of Azure Stack has gone into this application. Nothing, didn't know anything about Azure Stack. But because these two things are consistent, this application works perfectly with Azure Stack as well. So much so that Brad's going to bring up here in this, he's going to look at his storage, his blob storage in Azure Stack specifically, so on premises. So he's going to go into his Brad's demo resource group. He's going to look at the storage view, his blob storage, and he's going to see that there's nothing in there. And what he's going to do essentially, so he's got one blob that he's got available called Brad's stuff, or the stuff container. Here we go, come on. There we go. And he's essentially going to use that tool that's been developed for Azure, and the developers have no concept that Azure Stack was even available at this point, and he's going to utilize this tool to bring about change in Azure Stack. So that proves the APIs are consistent, the experience, the integration, it's there. It's there in Azure Stack. So all he's done at this stage is pointed this Azure Storage Explorer at the endpoint for his blob storage, and he's essentially going to upload a sample graphic, in this case just a simple announcement tweet that somebody made when we announced Azure Stack a little while back, and he's going to push that, and it's automatically going to upload that into his Azure Stack environment. So when we look in Azure Stack again in the portal, and he brings up he went to the wrong portal because they're so consistent. It's such an easy mistake to make. So he goes into his stuff container, and you'll see, come on, Brad, chop, chop. There you go, Thomas tweet. That's the one he just uploaded. So using a tool that was not developed at all for Azure Stack, just for Azure, works perfectly. And he can view the endpoint, and then he can look at the graphic, and it's just one where we showcased the announcement of Azure Stack at Ignite in the US back in May. There you go. So that, in a nutshell, walks you through a bit of the tenant experience, consuming it through the UI. We looked at a bit of the development experience as well, and how you can easily deploy applications using tools like Visual Studio, and how other tools just integrate. If they're built for Azure, they're going to work for Azure Stack, and that's the beauty of it as well. So let's go back to the slides. And then we think about apps. The apps we focused on there, the coffee shop app, web applications, containerized applications, they're all forms of what you say are probably next generation and cloud native apps. They've been built with the cloud in mind. But you've got a lot of traditional apps in your environment. SQL Server, SharePoint, Exchange, SAP, multi-tier applications. These are just as relevant on Azure Stack as Azure. And you can deploy them in many cases through the similar mechanisms, through ARM templates and so on, and yet you're running them on premises in an Azure Stack environment. You don't have to siphon off your infrastructures and have, well, traditional apps go on our traditional management view, and Azure Stack apps go on Azure Stack. That doesn't have to be the case. We can incorporate it all. Just like you can run Azure applications, SAP, SharePoint, SQL Server, and so on in Azure today. We can run it in Azure, we can run it in Azure Stack. So don't think that this is just for next generation modern applications. It's absolutely not. When we think about development processes and life cycles going forward, there's terms that get bandied around: infrastructure as code, configuration as code, DevOps, and so on. But Azure Stack is a big enabler of those kind of things, because you're able to present your developers and your consumers within your environment with a rich set of APIs that they can build applications quickly without the roadblocks or the hoops to jump through. They've got enough control over the infrastructure to be able to quickly deploy an app, and if they need to deploy a new version, they've got the power to do that. And yet they don't have to understand the plumbing and the storage and the networking and all of that, because it's all abstracted away. And that's very flexible, and that's something you can build, and as a service provider to them, that's what you can present, and they can consume that. So I touched on Azure Resource Manager before as a mechanism to define and deploy and applications and workloads that are important within your environment. And we saw how we executed one of those from PowerShell, but we didn't really go into the detail of what it's all about. Driving change within, when we deploy something, this Azure Resource Manager is pulling all the strings. It's telling you what we need from compute, what we need from storage, what we need from networking. And that's a significant piece of technology that we've brought from Azure and brought it into Azure Stack. And it enables us to control all of those key components when we're deploying applications and workloads. And who better to talk us through Azure Resource Manager than Rick, who uses it all the time. And Azure Resource Manager, it's been in Azure for a while. It's going to come in Azure Stack. You're going to have this available to you. So tell us and talk us through just what it means for the IT pro and the devs and so on. So,
Well, I don't want to get lost in which portal I'm on, because it's the local one or the other one.
it's so consistent. And that's the point.
So from an Azure Resource Manager perspective, this came out for infrastructure, which is where I started to pay attention to. It's actually been out for a while for non-IaaS type resources, but it came out in last May at the Microsoft Ignite in Chicago for the announcement that came out, and that's also where we talked about Azure Stack really for the very first time.
Yep.
I immediately jump into ARM templates because that's, again, stuff that I work with, stuff that I understand, infrastructure as code, and I forget that there's also this other part of simply logical groupings of different resources, the ability to segment off security and delegate out security to different people and different personas as roles. And in the Azure world, very important as well to be able to associate tags with those different resources and resource manager groups, because that's where you get to ding your internal customers and your users with being accountable for the spend of your Azure consumption. As opposed to getting one bill of a couple $1,000, I can now find out that $999 of that belongs to Pierre Romain in his demo that he left running in my account, and the $1 was the amount that was owed to me by Mr. Jeffrey Alexander. So
yes.
You can actually associate the blame where it's supposed to be associated when you start using the proper tags. So that's where tags come in as well. And obviously for all your compliance friends, that sort of stuff, the audit logs come into play as well to find out who did what and who changed what inside those different things. So for the Azure Resource Manager as a whole, it basically is like an engine that will take the input for things like ARM templates to be able to go off and to orchestrate the creation of these different resources across that fabric. So from an ARM template perspective or Azure Resource Manager template perspective, it literally is just a text file. A text file that's declarative in nature that identifies all the different resources, the schema that's being used, that is then used by yourself to define your project that you want to deploy, where your app is going to reside. It also is able to be used to change configurations of existing groups if you wanted to. It doesn't have to be a create. It can also be simply change existing attributes. And it declares everything that is required down to the level of subnets, IP addresses, access control list rules about who can talk to what, that sort of stuff. But then it kind of stops at that point after the machines are deployed, and it waits for an extension to kick in to do the further configuration. So I have arguments with my colleagues that are more PowerShell based and do all their management of Azure through PowerShell. And they're like, no, ARM templates, it's not going to do the thing I need it to do. It's like, no. You're still going to be using PowerShell. You're still going to be using DSC to do that configuration once the infrastructure's been put in place and also once the machines are put in place. That's where the extension comes into play. But you're going to be simplifying your life an awful lot more by declaring and defining that architecture with your ARM template. The other thing is, because it's a text file, obviously it can be source file checked in. I'm not going to show you that today. I showed you that last night in my session last night, a little bit later on today at 5 o'clock if you're interested with the concept of Git and how Git works in this case, or Visual Studio Online, if that's the tool of your choice. But where do you get started with Azure Resource Manager templates or ARM templates, and how do you understand where they work? Well, let me first of all kind of describe a situation. I mean, you had one for a very simple application. Has anyone here ever deployed SharePoint 2013 before? Anybody? Okay. Now, how many people have actually done SharePoint 2013 highly available deployment with clustered SQL backends and everything else? From all those people that put their hand up, I want to see two people, two very brave individuals that actually said yes. They're probably very highly paid consultants as well. Because it's not an easy task to be able to do. Well, we've actually automated that into a template with associated PowerShell scripts that anyone in this room can go off and deploy a highly available SharePoint 2013 farm with Active Directory, SQL Server, highly available, as well as front-end and back-end databases. And so to follow your video example, I have a little video here that talks about this. This ARM HA template originally used to be over 1,000 lines of PowerShell code. Now goes through with an ARM template and defines the very first dependencies of let's get the infrastructure defined and the Active Directory up and running, because nothing else works unless you have Active Directory in place from a SharePoint 2013 perspective. And so you can see here different snippets of the ARM template text files that are used to describe this. ignore the name primary and backup domain controllers don't exist anymore. It's simply AD, first and second domain controller. That's it. But when that's there, the depends on comes into play because that's when SQL can actually go off and start. And then the extension would fire off to be able to do the configuration of SQL. And then when that's done, the dependency then kicks off as well for all those different SharePoint apps and SharePoint web front ends as well to be able to go off and deploy. This is one template that you can go and download and use right now to learn about an extremely extensive, large template. I don't personally recommend you go down that path just yet. Baby steps. Learn how to crawl before you can walk, and yet alone do a sprint. Or use one of those hoverboard things that Cisco's given away here. I fell off of that already. You don't want to do that. The concept is, again, basically a declarative approach for that template, how it's defined, how it's built, and how it's done. And they basically will go through and orchestrate your deployment all across the different services that are required. That's why it works across both Azure Stack and also Azure Resource Manager up inside the Azure world. If I remember which switch I'm on, I think I'm on 8, which is this guy right there. Yeah, that's me. I thought I'd just quickly show you. Here is an ARM template that I've already downloaded and brought down to my local machine. If I can, where is it? There we go. So this is simply a local text file that's stored inside my demo templates directory structure off of my C drive for GitHub. And all our ARM templates or JSON templates have basically various different sections. The very first section being schema, which defines the version for what you're using for this template file, version 1, for all the different things. It then has a parameters section. Now, parameters basically are going to be the things that are prompted during the deployment of this template to be filled in because it's unique for this deployment. Based on the complexity of your template, you're going to have more or less of these different parameters that are filled out. Here's the very basic stuff for admin username and also admin password, stuff like that as well. Now, you'll notice I'm using Visual Studio Code here. Although you had a great experience here that Brad, I think it was, showed you using Visual Studio, I don't generally recommend as an IT professional you go off and install an 85 gigabyte software program to edit a 1K text file. And so I'm using Visual Studio Code, which is significantly lighter. I think it's only about 80 megs or something like that. It's quite nice. Because I'm referencing here administrative username, I can also see elsewhere inside the file where this is going to be called. As you can see here, for the OS profile, it's going to inject admin username variable into that ARM template on deploy at runtime. And then you also have passwords and OS versions and different values for there. This other one right here is quite cool, as you can go ahead and define all your different variables that are going to be used across your entire template that get injected at different points. And then here you can see, for instance, the size of the VM for this very simple machine being deployed. I'm going to change this to a D2, which is our faster CPU infrastructure. Costs a little more, which is nice, but you get way better performance. And again, you can also see where VM size comes into play down here later in the template file for the hardware profile for VM size, and then the cost gets involved there. And I'm just going to go ahead and save this guy. That's on my local machine. Pulling up my good old-fashioned PowerShell deploy, because I figured you'd rather see this being done through PowerShell. And to make sure I'm still logged in, I'm going to go ahead and double check, because I've been sitting here waiting for you to finish so that I could go off and do my demo.
Blah, 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 blah.
Now, the neat thing about this is I'm actually using PowerShell Preview for Azure RM, which is in version 1.01 right now. It's not designed to work in production, but it absolutely works in production if you want to take support into your own hands. The main reason I'm showing you this is also because it allows me, from an infrastructure perspective, my IT department at Microsoft has put in, you must use two-factor authentication to be able to use even command line tools against your subscription. And so I just logged in with my smart card that's on my box right here. Go ahead, there we go. I'm logged into my environment. I'm just going to double check, see what subscriptions are available. I have multiple subscriptions because, like a consultant that I am at different points in time, I have access to various different people's subscriptions. Each subscription is a barrier, basically, that allows me to define who has ultimate access to what, to do what within those different subscriptions. And then, so I'm going to go ahead and define my default subscription here to be my one that I call Rick Demo. This is the one that Pierre billed up $999 against the other weekend. So he's since been removed from my admin levels. And then finally, I'm going to go ahead and I'm going to use a new RM resource group deployment. So I'm going to deploy new resources into an ARM resource group. The name of it's going to be called Rick ARM Demo, and then the template that's going to be deployed is the C drive copy of this Azure deploy.json file that I just showed you earlier that I changed the A2 to a D2 as far as the machine is concerned. So go ahead and hit that. Show you this here. Here's my ARM demo resource group, which is completely empty at this point in time. I'll come back to him in just a moment.
So that was Azure Public Cloud.
That was the public cloud.
Yep.
Yes, I don't have access to ARM on the Azure stack. You've had it for a while, so I just use it up there anyway.
Yeah.
You got it. Now here it's prompting me for those parameters that I have to fill in. Storage account name, Rick AU Demo 1. Actually, I'm just Rick AU Demo, keep it nice and simple. My admin username for that user account on the Windows server that I'm deploying. My password, super secret one I don't want to share with anybody. My DNS name for public IP address, Rick AU Demo. Go ahead and deploy, running script. And if I flip back over here to my Azure portal, now I'll be able to see just how fast this is to be able to go in and have those Azure resources deployed. Oh, look, I've got a public IP address deployed right now.
It's rapid.
I like how you dissed me for being too slow.
No, that was a compliment.
I'm just doing this in a data center with 600,000 machines inside of it. So how many you got in your data center for your Azure stack right now?
Let's not talk about that.
Let's go ahead and refresh. Oh, yeah. Okay, here we go. I shouldn't have hit that button. I should have just gone back here instead. Here's my ARM demo. Oh, look, I've got my public IP address and my VNet right now. Because it's actually, I got an architecture slide, I think, on the next one, unless you took it out,
No.
that basically describes, I'm using one of a number of different methods to deploy. It could have been an ARM template directly from GitHub. It could have been an ARM template uploaded into the Azure portal. It could have been, like I demoed, an ARM template on my local machine using PowerShell, talking to my subscription to deploy, and then targeting my Azure subscription. It could have been any one of those, and it will then go in and tear apart that template, validate that it's all correct, and then go ahead and in parallel create all the different resources that are required to make a VM or the entire project inside of my Azure subscription. Let's go back one more and see if I got a refresh on this guy. My VM should almost be there. Still not yet. It's coming. Once it's gone ahead, it's now provisioning the storage account. The storage account gets provisioned. The blob, which is the operating system disk, comes down to the local blade inside my data center. All transparent to the end user. It simply knows which blade is available. It knows how big to make my VM because I said a D2. So it carves up the CPU, the compute, and the storage and networking on that guy there. And then it will go in and populate that OS, hydrate it, and then bring it up and have it access and done. This is going to take probably about another 7 minutes or so to finish off at this point in time.
The key thing, though, everything we've shown you there is, yeah, it's in Azure today, so you can get used to it, you can play around with it, and we'll talk about some quick start templates in a minute where you can get a leg up and start learning even quicker. But it will be exactly the same in Azure Stack. So you're not wasting time by learning and experiencing and building any applications because you'll be able to bring them on premises and run them in Azure Stack. That's the beauty of it. So everything that Rick's gone through there, the way he used it, the tools that he used, whether you choose to use the same ones or different, it's all transferable to Azure Stack. So that consistency is incredibly important.
So you mentioned the quick start templates. While I'm waiting for that guy to deploy, I'll come back to the slide in just 1 second.
Right.
This is on the Azure.com portal. Just go to azure.microsoft.com. You can go into resources and then choose templates right here, right there. And it brings up this lovely little search engine of all these different templates. It's actually pulling us from GitHub inside of our public repo that Microsoft manages of all these different templates. This is where you go to learn how they are created, how to build your own templates from a starting point, and also how to be able to go in and modify these to suit yourself. You really don't want to go off and start with a file new template blank and then start copying text files. Again, I'm not a developer. I'm not that well versed at being able to understand the squiggly brackets and the full commas and the stops and the half stops and the colons and the other things
comma?
And whatever. The what?
The full comma.
The full comma.
Instead of full stop and a comma.
You got it.
Yeah, excellent.
So the proper terms. You can basically come in here. You can that SharePoint one I mentioned as an example. There's the SharePoint deployment as an example. Let's take a look at it. If I wanted to actually look at that individual file itself, it's quite large for the build out. I can actually say learn more on GitHub. And then on GitHub, I can see my Azure deploy.json file, last updated 20 odd days ago. And this particular guy, so I scroll all the way down, It's 1,544 lines worth of code to be able to deploy a highly available SharePoint farm, SQL cluster, everything else like that. Again, don't start with this one. Just know that it is possible, and that you can definitely learn from it, learn from its experiences, to be able to have access and work with ARM templates. The one that I did earlier, which was very simple, Windows Virtual Machine 101, simple deploy. That one there is only about 30-odd lines, 40-odd lines of code, if that.
But it's standardized. That's the
It's all
key thing.
standardized.
That's once you've done once, you've got repeatable deployments of that particular example application, whether it be SharePoint or the single VM that Rick was referencing, and it's consistent.
And so the one thing that I will mention, this is something that's kind of interesting, I found this out a little while ago sitting on the engineering team for Azure, is that they're actually using those quick start templates, 101, 201, and 301 prefix on all those files. That's one of the benchmark tests to see if Azure Stack on-prem is working or not, is the fact that if they can be taken...
Not. What do you mean or not?
if they can be taken unchanged from the Azure Stack, so from the quick start templates repository, and have them to run as is on someone's Azure Stack implementation, and they work, ding, 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 we get it, it's good to go.
Cool.
And I think that's, where's my...
We need to go to the...
No, it's already there. I switched it.
Oh, right.
I'm faster than you think.
Yeah, absolutely.
So Azure Resource Manager, obviously we've highlighted this a number of times, the fact that, that those templates are being used as the benchmark to see if they're all happy and if they're working on both sides, on-prem and also inside of the Azure cloud.
Yeah, cool. So as Rick demonstrated and explained about the consumption of his subscription by others, Azure is an all-you-can-eat model. Azure want you to consume more. Rick wants you to use as much as Azure as you can humanly consume.
I was happy when Peter had a $999 bill on my account.
Well, yeah, and he'll bill you for it.
Center had to pay for it.
Azure will bill you for it. But on premises, in your data center, that's not as applicable. You've got a finite amount of capacity. In Azure, we can just add more. We'll add racks and servers and whole data centers if necessary. But in your data center, that's not a reality, or in most data centers, that's not a reality. So therefore, we need to be able to control more effectively who can access what services and put boundaries around how much of a particular service they can use. And so I want to show you a quick demo again of consumption of the Azure Stack and how it's slightly different as a service provider, as a service administrator, and how we start to put shackles around what people can use. But we want to make sure that, we want to make sure that people have still got flexibility to consume what they need, just not too much. So in this case, we're logged in as the service administrator. Remember those different role types that we talked about before. This person's not necessarily interested in the plumbing, but wants to make sure that they can provide the right services to their tenants. So we're just going to adjust the zoom so we can see, because we have an extra section on our menu there that's called Provider in the left-hand side. So when we click on Provider, that's going to give us a way to define who accesses what and what they can access. So when Provider comes up, you'll see we've got a single subscription, that's fine, that we're working with. But you'll notice that there are a number of registered resource providers in the bottom section of that view there. The resource providers are things that we can present or consume from the resource manager, like storage or network or compute or whatever it may be, SQL servers, that'll have a resource provider. Anything that we can present to tenants. And so we associate these resource providers with particular plans. And a plan is it's almost like a restaurant menu. When you go in, you get given a restaurant menu that's, in this case, very specific to you. You've got a bespoke menu, and it says, yes, you can have virtual machines, you can have SQL servers, you can have whatever, storage, networking, whatever it may be. Whereas when Rick logs in, we may just give him websites. It just depends. Yeah, I'm being a bit constraining there, but I don't want to burn through my data center. So those are defined in plans, and your users are attached to the plans through the role-based access control. So these plans, you define them within the Azure Stack. That's different from the Azure approach, but these enable you to be more constrained and more controlling, intentionally so, about your resources. And you'll notice actually there, if you look, you'll see that there are resources that we've got here that are actually grouped into different regions. So you might have multiple data centers. In this case, we've got one in Chicago, one in Paris. There's a CorpNet one as well. These different regions could reflect different amounts of resources and capacity. So you can add those to plans as well, so that when somebody chooses, well, I'm going to deploy my bakery application or my coffee shop or Rick's SharePoint farm, they're able to choose, well, where do you want to deploy this to? in a particular region, because that might be important to that particular application owner. Or we want to deploy this in Chicago or London or wherever it may be, or Melbourne or whatever. So you'll see here what he's doing is he's defining a new plan. He's going to give it a name. He's just going to give it the attendee plan. Before he finishes that, you'll notice in this section here of plans that have already been defined, the word public. Don't confuse that with public cloud. Public from a plan perspective means it's visible to tenants. They can subscribe to the plan. Okay, they can access it. If it was listed as private, it would be hidden from them. So he's defining a new plan. He's going to attach a resource group to that essentially says what resources can you consume, the ARM templates, the different virtual disks, whatever it may be, that's going to be important for that group of users and that plan. And he'll go from there. And it's as simple as that. We define those plans, and we then put the quotas on the plan. So I'll flick on a bit further here in the video, explaining what I've just explained. Here we go. So he's choosing the offered services that are going to be available for users of this plan. So he's going to choose network resources, compute, i.e. virtual machines, storage as well, blob storage. And not just is he going to make them available, but he's going to then put the quotas. So for compute, so for virtual machines, firstly, which region are you going to allow tenants to deploy virtual machines into? In this case, he's just going to choose, let's say, Paris or Chicago as an example. And then you've got the option to choose quotas. And this is where we say, you know what, I want you to be able to create VMs, but you can only create a maximum of X. X being, in this case, he's changing it to 100. We can adjust the amount of RAM and so on. There's a number of different metrics we'll make available. You don't need to do any of that in Azure because it's just a pay-as-you-go model. The size of your VM is reflective of the VM type that you choose. That's different in Azure Stack. So you want to make sure that you have enough control over the resources you're consuming for tenants or your tenants are consuming that make sure you don't run out of space and capacity within your data center environment. So that takes me back. Which one's the slide machine? Is it 5? There we go. Big number 5 drawn on the machine, so I should be able to tell. So that was a bit about the service experience. But now let's focus on the plumbing and some of the stuff that's under the covers. So we've talked about those first 2 layers. Then we think about the services that we provide. So IaaS as an example, virtual machines, virtual machine images, so the ability for users to create virtual networks, load balancers, disks, and so on. And then PaaS, platform as a service, websites, databases. These are all things that the tenants can consume from you in your environment. And when we think about what happens under the covers, we mentioned we've got regions. We showed that in the UI in the demo where you can essentially say, okay, this particular resource provider is available in 2 regions. So you can deploy VMs in Paris or Chicago, whereas websites you can only deploy to Sydney or London or whatever. You've got the flexibility to say that certain resources and providers exist in certain regions and present that through to your tenants. Useful if you've got multiple data centers. But what's underpinning these services? What's providing the power, the horsepower under the covers? Well, it's our core infrastructure investments, the cloud-inspired infrastructure in Windows Server and System Center. So Hyper-V is a virtualization platform, clustered for resiliency and redundancy. It's storage. We're not talking about SAN storage here. We're talking about software-defined Windows Server storage to transform commodity hardware into high-performance infrastructure that you're going to run your, in this case, Azure Stack on top of. And I'll talk about some of the investments more specifically in a few minutes. Then you've got networking that's linking all of these Hyper-V hosts and storage infrastructure on which your virtual networks you deploy on the Azure Stack reside. So it's using virtual networking and software-defined networking heavily to enable that. So if we look at these very complex architecture diagrams that we've illustrated here for compute, storage, and networking, down the middle, you've got at the bottom for the compute, you've got Hyper-V. The same Hyper-V you know and love in Windows Server, but it's Windows Server 2016, obviously. And that's giving us new capability for great scale, great performance, security, which I'll touch on shortly as well. And they're clustered for redundancy, providing a pool of compute resource that on top, we have the Azure Guest Agent, which allows us inside virtual machines to tweak after the infrastructure deployment has taken place. We've got the resource provider that controls the Hyper-V hosts from Azure Stack. And then at that top layer, we've got VMs, VM extensions, and platform images. These are things that tenants interact with and deploy. So they deploy a VM, and as Rick said earlier, once the VM has been deployed from a resource manager template perspective, it gets to a certain point where stuff needs to execute inside the VM to finish the customization. That could be a DSC script, that could be a chef or puppet configuration, it could be just some bespoke PowerShell you've thrown in there. Either way, those VM extensions execute after that main ARM template has got to the point of deployment that is relevant, and the deployment will continue. And the Azure Guest Agent enables us to do that. So that's using Hyper-V technology. Then when we think about storage, again, I said we're not using SAN storage. We're using software-defined storage, transforming commodity hardware, commodity being industry standard x86 servers and disks, SSD, SATA, hard disk drives, NVMe disks inside those servers, and we're transforming them using what's called Storage Spaces Direct. Now, if you're not familiar with what Storage Spaces Direct is, we introduced storage spaces, generally speaking, in Windows Server 2012. And that essentially said, okay, you take a number of Windows Server file servers, you connect them via SAS, so industry standard SAS, 6 or 12 gig, to a JBOD. That JBOD's filled with hard disk drives and SSDs for tiering. And if you need more capacity, you add more JBODs. If you need more compute at the file storage processing layer, you add more file servers. Low-cost solution, but when you combine all those pieces together, the software-defined storage technology in Windows Server transforms them into an enterprise-class storage repository. And it's simply accessed by // file share, which most Windows admins are familiar with. That was 2012 and R2. In 2016, we introduced Storage Spaces Direct. So instead of having that separate JBOD level, your file servers that I talked about, your Windows Server file servers, the disks go inside them. So your hard disk drives and your SSDs, whether they're SATA, SAS, NVMe, all of those different disk types are now supported, are in the chassis of the individual file servers. So you've got very disk-heavy file servers, but through software, we pool all of those raw disks, and then we transform across your file servers that are clustered together and create essentially shared virtual disks that span all of those storage nodes. So no external storage. It's all local to the individual nodes, but we span that across. So we're converging the storage layer. And that's powerful because it's highly performant, it's scalable, and it reduces the complexity of the data center. No SAS cabling, no external JBOD storage is necessary. So that's Storage Spaces Direct, which is powering the storage layer of Azure Stack. But also we've got REFS, and you think, oh, REFS, that was introduced in 2012. Is it ready for the prime time? I'll give you some indication of one of the benefits of REFS for Windows Server 2016. The VHDX, so our virtual hard disk files, accelerated operations. So what does that mean? So I ran a test, and I was in the office next to Rick, and I kept running into his office and saying, you've got to listen to this, when we were back at campus. I configured a volume with NTFS on a single spinning disk. So no SSD, nothing fancy. Half of that disk I allocated to a volume with NTFS. Half of the disk I allocated to a volume with REFS, the new resilient file system, which is underpinning the Storage Spaces Direct. I provisioned a 50 gig virtual hard disk of fixed size. Now, if you've ever provisioned a fixed size virtual hard disk, it zeroes out all the blocks and it takes a while. Now, on this single spinning disk with the two volumes, when I provisioned it to NTFS, it took 35 minutes. When I provisioned the same 50 gig fixed virtual hard disk to REFS, it took 1 second. It's phenomenal performance. So if you imagine your VM deployment, when you're waiting around for that virtual disk to get pushed out, that's going to be rapid. And REFS is going to enable that for us, as well as the improvements in performance, scale of the file system, the resilience of the file system as well, hence the name. So that's something that underpins our storage. But you know what? It doesn't matter for the tenants. They couldn't care less because it's all abstracted. From an Azure Stack perspective, all they'll consume as a tenant is blob storage, just like they would in full Azure. You don't see people going to Azure and navigating through C volumes and D volumes and stuff on the underlying physical infrastructure in Azure. It just doesn't happen. All you get is a storage account, you create a blob and tables where relevant, and that's where your stuff goes. And each item has a link that you can link to. So blob storage in Windows Server is a new feature in 2016 that we're exposing for the Azure Stack. So that means that when you're writing your applications and so on as a developer, that's why you don't need to know what the underlying plumbing looks like. You're just consuming blob storage in the same way on-prem as you do in the Azure cloud itself. So again, another example. Then when we think about networking, we've got that underlying data plane, which is where our Hyper-V hosts are connected. They're all integrated. They're utilizing the networking you've provided. But then on top of that, we layer powerful virtualized network capability. And I've got a brief demo that I'll show you with that in a second. And that's all controlled by one of the new investments we've made in Windows Server 2016 that we've taken from Azure called the Network Controller. And the Network Controller is a centralized, scalable, automatable component of Windows Server that we've taken from Azure, put into Windows Server, that enables you to control all of the key aspects of the network, from the physical switches and routers, through to the virtual switches on the Hyper-V hosts, through to the virtual networks you're deploying, and controlling a lot of our network functions like firewall and load balancer. And speaking of load balancer, we've built a new load balancer into Windows Server that we took from Azure, where it's been running at hyperscale. We took the same code, the same load balancer, and we put it in Windows Server. This is not an evolution of NLB. This is not the next NLB, it's not the brother of NLB, it's nothing to do with NLB if you're thinking, is this NLB? No, it's not. This is a new software-defined or software load balancer, pioneered and built in Azure, serving billions of flows in Azure. We bring it on-prem. And that's, again, controlled by the load balancer. And what pulls the strings on all of that is the network resource provider. Just like the compute resource provider pulls the strings on the compute layer, Hyper-V, and so on and so forth. So I've got a quick demo on this one that I can very quickly show. Hang on. Just to show you what it looks like. So what we're going to do, yeah, we're on, is run a command where we're going to create a new VNet. So we're going to create a new virtual network. It'd be the same as me going to the Azure portal and saying, I want a new network. But again, we've defined it in a template, a resource manager template. So we create it, we run this PowerShell to execute it, we give it a name called DemoX in this case, and it gets deployed. And if we pop over to the portal, if I quickly go forward, you'll see under demo, it's created our DemoX virtual network there. So that would mean if I deployed virtual machines and applications onto that network, they could communicate together. And that's great because it surfaces through Azure Stack the same way it would surface if you created a new VNet in full public cloud Azure. You can see your subnets that you've created, you can see your relevant DNS services, and anyone who's got access to this through RBAC. And there's the tags that Rick talked about as well, how you can start to see and define those. But if we go to the on-premises view, if we go back to PowerShell quickly, and we have a look at what happened under the covers, so when we show network fabrics, and we run that, this is just going to show us, actually, we did that for the Azure Stack, but how was it created on our plumbing? What does that look like? So when he executes that command, you'll see we created the virtual network. It sits on a logical network, so there has to be something that is connecting all of our Hyper-V hosts together in this infrastructure. And if we deploy lots of VMs in our DemoX virtual network, they need to talk. And if they need to talk, eventually the traffic will need to go via the physical network to connect those VMs. It can't just jump between physical servers. If you want to talk between two VMs that are on separate hosts, the traffic does need to traverse the physical network. And that's what that logical network is saying. We use that logical pipe, the plumbing, to transfer this network virtualized traffic. It's encapsulated, it's isolated, you wouldn't see it on the physical network, but it's using it. But one other thing that I want to point out, and this is new in 2016 as well, and again, another example of how we're using the underlying plumbing in Windows Server, is you'll see the network virtualization protocol, and we highlight it here in a sec, is not our network virtualization generic root encapsulation, which is native to Hyper-V. We're actually using VXLAN. So we support heterogeneous network virtualization protocols in this release as well. So that's useful to know. And then as he goes on, you'll see the VNet that we created, DemoX, is just listed down here. It's a very raw view in PowerShell, but it gives you an idea that the impact and the change that tenants are making through the portal or programmatically, that's what's happening at the plumbing level. So you can see that if you're the infrastructure administrator. So let me go back to that. And to wrap up, so, to wrap up the cloud-inspired infrastructure, we talked about VMs and the APIs and the resource provider that consumes those, and the same for network storage. One key area around that we didn't talk about was security, and there's a new capability in Hyper-V called shielded VMs. Particularly important if you're a service provider or you're working in a very sensitive enterprise-type environment where you want to ensure that your fabric admins, the guys and girls that control the Hyper-V host and the storage layer, don't have access to the VMs, inside the VMs. Because especially if you're a service provider, that was quite a loud bang. If you're a service provider, then you've got to ensure that your customers trust you. Because it would be very easy for me to go to Hyper-V as a service provider, open the virtual disk of a virtual machine that I'm hosting for Contoso or Fabricam. I could just copy that virtual disk off over here onto my workstation, double-click it, mount the virtual disk, and have a look. Let's have a look at their Active Directory domain passwords or whatever I can do. Shielded VMs puts an isolated barrier around that, enabling us to isolate the Fabric admin from the VM owner so that we ensure that level of control, and the virtual machine is encrypted as well, which is particularly important for compliance. So there's some cool stuff there. There's some great sessions that you can view on channel9.msdn. Was it channel 9, MSDN? channel9.msdn.microsoft.com? Just search channel 9, and you'll find...
channel9.msdn.com.
Right, that's it, yes. And you'll find some sessions on there as well. So, the summary of the show, summary of the session. We're bringing private cloud to you. We're bringing Azure innovation to you in the form of Azure Stack. It's not available today for you to try. It'll still be a little while out before you will be able to get your hands on it today. But you can get started today in a couple of ways. You try the Resource Manager in Azure. Get used to it. Play with the samples. Try it out for yourself. Get your developers on board and understanding why this is important. You can play with the preview. The Technical Preview 3 is available today. Technical Preview 4 for Windows Server and System Center is very, 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 very close. And if you want to get used to the methodologies, the way you can deploy services and applications and infrastructure for your tenants, your users, then the Azure Pack, not Stack, the Pack, the currently available version, would enable you to get used to that. The Azure Pack is a free download for Windows Server and System Center. It sits on top of Windows Server and System Center, and it will support 2016 Windows Server and 2016 System Center. So even if you choose to invest in that for the time being before Azure Stack comes along, you can get used to it and so on. And there's loads of resources online for that. So with that, thanks to Rick for helping us out with the Azure Resource Manager stuff. Hopefully it gives you an insight into what Azure Stack is all about, and let us know, how we can improve, and thank you for your time.